Good morning all. This is a battery monitor. Alternatively, it's a VA meter. I think it's also a coulometer. I think the manual says slightly more on it. Yes, it's a DC voltage and current meter. Also a coulometer. Model KG140F series, specifically model KG140F. And it's made by Junctek. Or specifically the Hangzhou Junts Instruments Company Limited. So the story behind this is that the manufacturer got in touch and said, we are the manufacturers of the VAT1030. Now that was a 100 volt 30 amp voltage and current monitor. This is in a different league. Let's get the current shunt out. So that's the screen module, this is the electronics module, and this is the current shunt with a few other bits and pieces. But this current shunt is pretty massive. There it is. It's enormous. I'll get some light on it. So yeah, the current shunt is this enormous slab of metal with these sort of veins running between these two blocks. And you can see there are little cuts there, little nicks, which presumably has been done to calibrate this unit. There's a PCB on the top with a JST connector. These bolts, they're not 8mm because my 8mm connectors simply don't fit. I think these are 10mm. They're absolutely massive. Also supplied, these aren't supplied, also supplied in the bag of bits are these. Look like pure copper, absolutely massive crimp terminals, I suppose they are, and they say on there 400 amps. So I'm pretty certain this is a 400 amp current measuring device. I'll just measure the diameter of this bolt that's supplied, and yeah, that's 9.7, so that's going to take a 10mm ring terminal. It's pretty big. Lots of other bits in here, including there's a temperature sensor there, so the display presumably has temperature and also temperature cutoffs and that sort of thing. Big spanner for those nuts and bolts. There's also various interconnecting cables, but I saw these, and these do fit over these bolts. So I don't know whether these perhaps go on here and provide mounting points for attaching this to something, since it doesn't have mounting points of its own. Right, let's get the remaining bits out of the box. There's this, I think it's an RS485 cable, I think, with RJ45. No, there'll be something else connectors, won't they? There's also the screen unit, and there's the electronics box unit there. So in the manual here, there are two wiring modes. There's self-powered mode, where the unit, the electronics box, is powered from the battery you're measuring. Now that means that you've got to have a supply of between 10 and 120 volts. Or you can do external powered mode, where you have a separate battery to power this unit. And that, of course, can do 0 to 120 volts. Well, I'm quite happy with the 10 to 120 volt range. So I'll set up something that lets me do self-powered wiring mode. So in amongst the parts supplied are this short length of black and red wire. I think I'll solder that to an XT60, and then I can plug a LiPo into here, which will be about 16 volts or something like that. This will go into the little green connector, which is that, and that goes into the electronics box. So I'll solder that up. We'll take a look at what comes up on the display. I'm even going to use the little screwdriver supplied to fit these wires into this supplied block. So V-Sense is at the top and ground is at the bottom, so I'll screw those in. Right, let's power this up with this LiPo, so about 16 volts. Right, so most definitely V-Sense is pause, ground is neg. Flat side of that is pause. That lines up with that, so it's definitely the right way around. Let's plug that in. Oh, we've got a flashing green light there, So I guess the next thing to do is put this data cable, it's data and ground and 5 volts between the electronics box and the display. See what happens. Right, let's plug that into there. Oh yes, that's quite nice. So 15.43 volts. Of course, there's no amps because there's nothing being measured by the shunt. We could connect that via its cable to the shunt connection, which I believe is there, the current sensor, the middle one. I'll do that and see if, well, there shouldn't be any offset, should there? Because it's measuring 0 volts here. I don't know what circuitry is on this PCB actually. Let's just see what happens. Right, that's interesting. One way round, the colours don't quite line up with ground and VCC, but the other way around they do, so I'll do it that way around. It wouldn't actually matter, I don't suppose, which way around I did it, but VCC, ground, sense are on blue and yellow. Let's plug that into this thing, see what we get. And yeah, there's a small offset current there. Now there is a calibration procedure where you can set that back to 0, but I shan't worry about. Actually, that is reading 300 milliamps, which is quite a lot. So we'll look at that a bit later on, but that's that part working. Now there's another cable in here, which was the thermistor. So let's get that connected. Yeah, at the moment you can see that it's got -- degrees Celsius, so let's plug this in. I think it's got to go that way. Don't suppose it matters really. I don't think these are polarized components, are they? And we've got a reading of 20 degrees C, which I guess is about right for this room. Oh, more like 18 really. Now I noticed that the current has gone to 0, which is interesting. I wonder if things had to warm up a bit. Or maybe there's an auto calibration thing. I'm going to try and put some current through this shunt with this battery and this bulb. It's going to be an absolute lash up. But let's just see if I can get something going through there. Oh, we can't see the display, so let's work that way. I can't even see whether that's lit up. Yes, it is. And we've got 400 milliamps. Well, that seems to work. I mean, it's not very precise because it's designed for enormous great currents. This is interesting. When the customer starts the meter for the first time or restores the factory settings, the display will have a small current deviation under normal circumstances when the meter is not connected to the load. At this time, the charging state arrow and the discharging state arrow will jump back and forth, which means that the meter is being calibrated automatically. This phenomenon will last about 30 seconds, and then the current will return to 0 automatically. At this time, we need to press the key for a long time to confirm that the current returns to 0 so that the meter can remember the 0 state, and the 0 current will not jump again no matter whether the machine is switched on or off or restarted. So it does do an initial current calibration. I need to press something for a long press. I don't know what. Let's press OK for a long press. Maybe that did something, I don't know. Right, so what can we do with this thing? Well, let's press set. And there are all sorts of parameters here. Language, clear current, clear data, amp hours present, preset, amp hours remaining, brightness, LVP, OVP. Oh, I need to scroll down to go to the next lot. OCP, NCP, OPP, OTP, recovery time, standby time, voltage calibration, current calibration, temperature calibration, address, I think so you can have multiple units, delay time, current ratio, monitor on and off, relay mode, restore all. Now if you do restore all, I think it goes through that current calibration thing again. So one of the first sections in the manual says preset the battery amp hour value. Now this is currently saying, if you can see it, 79%, but I don't think this is just some guess based on voltage. I think what this does is it genuinely Coulomb counts. So you set the amp hours total capacity, and then you tell it where you think the battery is currently. So you can either fully charge it and set it to 100%, or you can fully discharge it and set it to 0%. Let's see if we can set this to, I don't know, 100% it's just measuring the voltage of that at the moment, so it doesn't really mean anything. So let's go into settings and go to amp hour preset. Now it's got 20 amp hours. I'm going to change it to 24. Oh, okay. Yeah, you can do that in increments. Okay, set. So is that 24 amp hours set? Let's go back into set. No, it's still set to 20 amp hours. Why didn't it remember it? Maybe you have to OK your way through each of the digits. So that's the 0.1, that's the units, tens, hundreds and thousands. Now there's no highlight, so maybe if I press set now, has it set it to 24 amp hours? Yes, it has. It's remembered it. And now it's saying 66% state of charge, and there's an amp hours remaining. So that's obviously set to, or was set to 16 out of the 20 amp hours this was previously set to. It's now, of course, 16 amp hours out of 24 amp hours, hence the recalculated percentage value. Now, there are a whole lot of sections in here like under voltage protection, over voltage protection, positive over current protection, negative over current protection, over power protection, over temperature protection. And they all say at the bottom, the protection function needs to purchase the relay. If there is no relay, please do not set this value, and install a relay in the circuit before it can play a protective role in breaking the circuit. So you do have to purchase your own relay. Now there is a relay output on this box here, output control. We've got a ground, an out, and a V external. So this is where you hook up your relay, and then if any of the protections needs to disconnect the circuit, it will do it via your external relay. There's no relay built in, and that makes perfect sense because you might be trying to switch 400 amps and they're not going to put a 400 amp relay in this little box. However, sneak peek, 500 amps, 24 volts. Now, there's a whole bunch of stuff in addition to this. Reverting time protection. This appears to be, if you set it to 0, then if a protection kicks in and then the situation resolves itself, it will immediately switch the relay back on, but you can put a time delay in that. Enter standby time. I think that's the time where the display turns off. Voltage calibration, current calibration, temperature calibration, set address. I think that's for multiple units. Set delay time. Better read that. I don't know what it is. Okay, this is for any of the over voltage, over current protections, that sort of thing. You can tell it not to trigger immediately, but put in a small time delay. So that's presumably to eliminate jitter if you've got something that is constantly triggering in and out of range. Monitor function. Oh, turned on using the computer software control. Don't know what that is. Relay mode, you can switch that on, and restore factory settings. I think that's pretty much everything in here. Yeah, the wiring modes, the connection of the relay and its external power supply. Now, whether that can be ground, whether that is ground referenced to the input voltage, I don't know. I'll have to check whether you actually need an external power supply. There is an app, Bluetooth, so I presume one of these boxes, not sure which one, which I might open this up in a minute, has a Bluetooth module in it to run the app. And that's pretty much it. So yeah, let's take out the current shunt. I know you're not meant to pull on the wires, but it's almost impossible to pull JSTs out without doing that, because how do you get, I suppose you can just about get a grip on that. Display unit can come out and my power supply can come out. Yeah, let's take a look inside here and see if this has got the Bluetooth. Oh, that's the little switch for whether you're using the 2-wire powering method, which is what I did, just using V-Sense to actually power this. If you switch the little switch to 3-wire, I imagine, oh, it's quite deeply buried in there, I imagine it wouldn't power from V-Sense. It would require to put the V external in, so it probably just switches between V-Sense and V external to route power into the electronics inside here. Right, inside the electronics box, there's the little 2-wire and 3-wire switch. We have this. Okay, so looks like we've got a buck converter here, so that's probably to bring whatever voltage you put on here. And remember, this can go up to 120 volts down to something that this can work with. Looks like that might be a microcontroller. Everything is etched. All the chips have had their tops etched off, including this MOSFET, which seems rather pointless because that looks like it's the relay switching MOSFET. It's going to be a generic part, so quite why that needed to be etched, I don't know. So let's have a closer look at this. Regulator possibly, but I can't tell you what anything is apart from that 1 ohm resistor because everything has been etched. That chip has got a crystal next to it, so that's probably... wait a minute, we've got an antenna there. That could well be the Bluetooth chip. That's interesting, it's actually integrated on the board. This then is highly likely to be a microcontroller. There's the programming interface for it. Is there another crystal around here? No, it's probably using its internal RC oscillator. Not sure what that 8-pin chip is. There are several of them. They could be op amps or something simple like this. So not a huge amount in here, but everything you would need to perform the functions that we've seen. And yes, the Bluetooth app is probably running in conjunction with that chip there. And just for good measure, I thought I'd take apart the display, but there isn't a lot to see. There's a flexible PCB in there, a connector, a display controller, presumably 4 switches, and a rubber thing to press onto these 4 switches. Yeah, so not a lot to see in there. The chip obviously has some sort of RS485 interface. Yeah, so that's quite interesting. Okay, let's put that back together. Oh, maybe not. Maybe that chip there is an RS485 interface chip, because that's the connector there. We've got some resistors, and then that runs up to this chip. Yeah, so that's RS485, and this is the display controller. Nothing else in there. So I've just hooked this up, and it appears to be doing that calibration thing where these things change color. So it's blue currently on that arrow, now it's red on that arrow. And so once it's done that for a few seconds, it should zero out the current measurement. Yes, it has, even though actually we don't have the current measurement device plugged in. But that was... Now I've just powered this down, so I'm just wondering actually whether losing power causes this to reset itself. Interesting. What are the settings for... Oh, it's to remember the 24 amp hours. Whether it's remembered the current calibration or not, I don't know. Yeah, so I think it's now got that wrong because the current shunt wasn't plugged in. So I should be able to go into set, come down to clear current. Okay, set current to 0. Okay, completed. Come out of set, and yeah, that zeroed out the ammeter. So that was the first look at this DC voltage and current meter, and also Coulomb meter. Now you're obviously going to see a lot more of this because I am going to try and integrate this into my solar crypto mining system, particularly for when the currents start getting quite large. This is going to be very useful for measuring those higher currents. Now, what about purchasing this device? I talked to the manufacturers about a purchase link, and they said, yes, they'd given me a link which is ship24.com/ZH. I'll put that in the description below. I've never purchased on that site before. I would imagine if you look out for this thing on AliExpress, possibly even eBay, you're likely to find it. I think it's a relatively new model, but it should become available from the more familiar purchasing sites in due course. Now I was just thinking about whether or not this could take the place of my load controller, which switches on the load when the battery gets to a high point and switches off the load when the battery gets to a low point. But I don't think it can, because both the over voltage protection, it's on the previous page, and under voltage protection, have timing functions so that you can tell it to revert after so many seconds, but that's not what I want. Or if you set the time value to 0, then of course it won't revert to switching the relay back on unless you press the OK button, so it would require a manual intervention. So this will certainly be useful for measuring current, voltage, and also accumulated kilowatt hours, watt hours, coulombs, which are of course watt seconds, I believe they are. No, amp seconds, coulombs, aren't they? Watt seconds are joules, that's right. But I will still need my load controller for the switching functions. So I may not end up using the relay switching part of this. It may just simply be a monitoring device. But anyway, that's a first look at this KG140F DC voltage and current meter, or coulomb meter, from the Hangzhou Junts Instruments Company Limited. Big thanks to them for sending this to me. Cheerio.